Hello everyone. In this video I'm going to do question 31 from section 15.2. The question asks find the volume of a solid bounded by the cylinder x squared plus y squared equals to 1 and the planes y equals to z, x equals to z, 0 and z equals to 0 in the first of them. In general, if you have a surface given by a function f of x, y, and you're trying to find the volume of solid under the graph of this function on the region D. So what you need to do, you need to form this double integral with f as its integrand, and then evaluate. That easy. So in this specific case, we have to first see what is this function, what is the region, and then go use that formula and evaluate the volume. So let's first see what is this solid. First thing is, X, Y, Z. First thing is that I have the cylinder x squared equals to y squared equals to 1. So as you know, this in xy plane, it is circle. And since there is no z, that means you have the same circle on all the heights for all z. So basically you form this cylinder. The second thing is the plane y equals to z. Y equals to z, so if you have just y z plane, this basically gives you the line. But since we are in 3 dimensionals, it is going to be a plane cutting through our cylinder. And when you cut cylinder by a plane, you get wedge, a circular wedge. But it says it should bounded by x equal to 0, so you just forget the back part of that, just half of it. And then z equals to 0, that's xy plane, and it is in the first octave. That's just basically the solid we are trying to find its volume. Is 1/4 half of wedge, a circular wedge. Okay, so in this case, the top part is our function, which is given by z equals to y. In other words, my function is f of xy. What about the region? The region is the shadow of that object on xy plane. So basically, my region is given by all x, y's, such that, first of all, this is circle, 1/4 of a circle, so it is all x squared plus y squared less than equals to 1. And then we know that x is bigger than 0 and y is bigger than 0. Okay, great. Now we have all the pieces together. I can rewrite this d in nicer way. Let me do that at this stage. So x, y. Let me write it up there. You can do it up here. So d is all x, y's. Let me write it in type 1 form, meaning that my x goes between 2 numbers and my y goes between 2 functions of x. In this case, you can easily see, so basically I'm trying to rewrite 1/4 of this disk, yes? And the radius is 1, so x goes from 0 to 1. Y goes from 0 to the circle itself. In this case, it is given by 1 minus x squared. So now we have very well description of our region, and then we can go ahead and find volume. Volume is given by f of x, y is y, dA. I have to now put in boundaries, so for boundaries, I have x goes from 0 to 1, y goes from 0 to root 1 minus x squared. Y is there. The inner variable is dy, and the outer one is dx. Okay, now I have a iterated integral. Do the inner integral first, and then do the outer one. Inner one is half of y squared. The boundaries are 1 minus x squared, 0 to square root of 1 minus x squared dx. And now I can use fundamental theorem of calculus, plug in upper boundary in antiderivative, minus plug in the lower boundary. Okay. This is going to be half minus half of x squared dx. It is just an easy regular integral. So antiderivative of half is half x. Antiderivative of half x squared is 1/6 of x cubed. Go from 0 to 1. And fundamental theorem of calculus, half minus 6 minus 0. And this gives me 3 minus 1 over 6, which is 2 over 3, 2 over 6. And it is equal to 1 over 3. So the volume of this guy here is 1/3 of cubic unit. So very quick wrap up. When you're trying to find volume of solid under the graph of a function, you integrate that function on the given region. In the specific question, we had to find the region. We found it integrating, plugging boundaries. You get iterated integral, do inner one, outer one. The volume would be the value of that integral, which was in this case 1/3. Thank you for watching this video.